Hello class, I'm going to go ahead and zoom in on these notes so you can start copying. That is the first half if you want to pause it. This is part of that plus the second half if you want to pause it now. Alrighty, so today's lesson we are going to be talking about greatest common factors and least common multiples. The LCM and the GCF. And I know that this is something that we've done before, but we're going to take a look at it in case you ever need to reference your notes. The question is, how can I find the LCM, least common multiple, and the greatest common factor, or the GCF, of two numbers? So there are going to be two different explanations here, one for the least common multiple and one for the greatest common factor. So let's start here. For the least common multiple, we are just going to list the first 5 multiples of each number and identify the smallest match. So basically that just means count by that number 5 times and look for a number that matches in both sets. So in our first example, or our only example, we're going to take a look at 12 and 15. So here's our numbers. We're 12 and 15. And like it said, list the first 5 multiples of each. So when we're doing multiples of something, we start with that number and we count by that number. So start with 12. 12 plus 12 is 24, plus 12 is 36, plus 12 is 48, plus 12 is 60. Okay, and with 15, we start with 15 here. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60, plus 15 is 75. Another way to think of it is to multiply our original number by whole numbers going in order. So you could say 12 times 1 is 12, times 2 is 24, times 3 is 36, times 4 is 48, and times 5 is 60. And the same thing for the 15. The 15 times 1 is 15, 15 times 2 is 20, 15 times 3 is 45, 15 times 4 is 60, 15 times 5 is 75. So anyway, then we go back through here and we take a look and see if we can find a number that matches. So we got 12, 24, 36, 48, 60, 15, 30, 45, 60, 75. Obviously, the only ones that match here are the 60s. Now, if, let's say, we went through here and we were counting, by 1, by 2, times 3, times 4, times 5, and then we get to the 5, and then down here with the 15, we go 15, 30, 45, yada, yada, yada. And we don't have a match. So we list 5 on top, and we list 5 on the bottom, and we don't have a match. Then what we would do is we would just go ahead and list a few more on both sides. So like, for instance, let's do a quick example. Let's say we do, let's try, 7 and 10. 7 and 10. Those work. Okay, so let's list the first 5 multiples of 7. So you got 7, 14, 21, 28, 35. Okay, so that's the first 5. And then for 10s, we've got obviously 10, 20, 30, 40, 50. Okay, so no matches yet, right? We don't have a match. So let's list a few more. So in here on our next to our 7, we'll go 42, 49, 56, 63, and 70. So that's 5 more. And then we'll do 5 more. On the 10, we've got 50, 60, 70. Oh, there we have 70s. The 70s match. So if the first 5 doesn't work, just list a few more until you find some that match. Anyway, come back here to our notes. Get rid of some of this excess stuff. Okay, so that is least common multiple. Just list the multiples until you find one that matches. Now we can take a look at greatest common factor, or the GCF for short. Okay, so when we are trying to find the greatest common factor of two numbers, this is the steps we take. Oops. We list all of the factors of each number and identify the largest match. So like the least common multiples, we listed all the multiples and found the smallest match. Here we are going to list all the factors and identify the largest match. So in our example, we have 12 and 20. And again, we've done factors before in class, but let's take another look here. We start with 12. The first factor of any number is always 1, and I think it is best to list the factors in terms of pairs. So you start with 1 and you say, well, what times 1 gives me 12, and that is 12. So 1 and 12 go together. And then after 1 comes a 2. 2 times what equals 12, and its partner is 6, because 2 times 6 equals 12. And then we come to the next number after 2, which is 3. We think 3 times what gives me 12? 3 times 4 equals 12. So now that the 3 and the 4 are right next to each other, and if we were to keep going, it would start to repeat, we know that we're done. So we have the factors of 12 are 1, 2, 3, 4, 6, and 12. And they are listed there in order. Same thing with the factors of 20. Always, 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 the first factor is 1. So we start with 1 and we think 1 times what equals 20? Well, 1 times 20 equals 20. Next number after 1 is 2. Does 2 go into 20? It does. So 2 times 10 equals 20. Then we take, we would think 3, and we know that 3 doesn't go into 20, so we move up to 4, and we think, okay, 4 times 5 equals 20. So 4 and 5 are connected. And then we would start to repeat because the 5 is already here. So we know we're finished. We got 1, 2, 4, 5, 10, and 20. And we try and find the largest one that matches. So obviously, it's always going to have a 1 that matches. This one has a 2 that matches. But the biggest one that matches is going to be this 4 here, which is already circled for us, but I'll circle it again. So 4 is the greatest common factor. It's the biggest one that matches. And down here at the bottom, I put in just a little helpful reminder if you ever forget what a factor is and what a multiple is. It says, remember, multiples are the same or bigger, factors are the same or smaller. So multiples start with whatever the number is and get bigger. Factors start with 1 and only reach a height of the number itself. So factors are smaller, multiples are bigger. Anyway, hope that helps. It'll be a nice reference for you in your notebooks if you ever need it. Whoops.